Today we continue with the application of differentiation. We shall specifically be looking at the following areas: the rate of change, the small change, and comparison of rate of change. Rate of change. dy over ds is interpreted as a rate of change of y with respect to s. Let's take a look at some examples on how to calculate the rate of change of a given function. Number one, what is the rate of change of the volume of a hemisphere with respect to its radius r when r is equal to 2? Solution. First and foremost, we are talking about the volume of a hemisphere. And what is the volume? So the volume V of a hemisphere is equal to 2 all over 3 and then pi r cube. You will recall that the volume of a sphere is 4 all over 3 pi r cube. A hemisphere is half of a sphere. Now with this we can find dv all over dr. That is the rate of change of v with respect to r. And that means differentiating this function. That's 3 times 2 all over 3. Multiply this by pi and then times r all squared. This simplifies because the 3 will cancel. We now have 2 pi and then r squared. Now we are interested in the rate of change of the volume with respect to its radius r when r is equal to 2. So you will evaluate dv over dr at r equal to 2. In this regard, we now have 2 pi and our r is now 2 all squared. 2 squared is 4, 4 times 2 is 8, and the final solution will be 8 pi as the volume, as the rate of change of the volume of a hemisphere. So that gives us the solution as far as this case is concerned. So we have 8 pi as our answer. Let us now look at small change. In terms of small change, we are looking at a delta y. This is pronounced delta y. So let delta y be a small change in the value of y that corresponds to a small change delta s in s. Then delta y is approximately equal to dy over ds times delta s. Let me explain this. Maybe you are preparing a meal. Maybe you are cooking something like rice. You're preparing rice. It could be jollof rice, it could be fried rice. Now, the moment you are adding an ingredient, say salt. If you add salt into the meal, the taste of that food will be at a certain stage or level. Some will say, oh, the food is too salty. Some will say, oh, the food is without enough salt. But assuming it is without enough salt and you added a little, you will have also changed the taste of that meal. In other words, that change you have introduced by that little salt is what we are referring to as the delta y, when there is a corresponding change in the taste of that food. So we look at a small change as differentiating the function and multiplying by the corresponding change in s, which we call delta s. Let's take an example. If y is equal to 2s squared, Find the approximate increase in y when s increases from 5 to 5.01. Your solution. Here you are giving y equal to 2s squared. You are looking for the approximate increase in y. So first and foremost, let us differentiate y with respect to s to give us 4s. Then of course, the next thing is to let your delta y be the small change, and this is approximately equal to your dy all over ds multiplied by delta s. Now, your dy over ds is already 4s, and the small change in s is from 5 to 5.01. So that means 5.01 take away 5. And this will result in 4s multiplying 0.01. Now, you will recall that the changes is from 5 to 5.01. Therefore, we have that our 4 times 5, the original value, times 0.01. This should be equal to 0.2. And this is the change that is required. Example number 2. We are told that if k is equal to 3 root s, we are to find the approximate increase in the value of k if s is increased from 4 to 4.01. This is quite similar to the problem we just solved, but the more problem we solve, the better for us to understand. So practice makes perfect. So here we have k is equal to 3 root s, and that can be written as 3 into s raised to power half. Now we can find the derivative of k with respect to s. That will give us half times 3, and then s raised to power minus half, because half minus 1 will give you minus half. So eventually this is going to be 3 all over 2 times 1 all over s raised to power half. You can go on and say this is equal to 3 all over 2s raised to power half. Good. Remember that we are looking for the approximate increase in the value of k. So let the approximate increase in the value of k be delta k. And this delta k is approximately equal to our delta k dk all over ds, multiply this by our delta s. Now, what would this be? Your dk over ds is equal to 3 all over 2 into s raised to power half, and your ds is 4.01 take away 4. And so we now have 3 all over 2. Our s from the originally, s is increased from 4. So we have 4 raised to power half, and multiply this by 0.01. The result of this is 3 all over 2 times 2, multiply this by 0.01. If you multiply that, what will you get at the end? So let's see what will happen. We'll have this to be equal to 0.0075. If you simplify this, recall that this is 3 over 4 times 0.01. And that is 0.75 times 0.01 to give you 0.0075 as the approximate increase in the value of k. Example number 3. The surface area A of a sphere of radius r is given by the formula A equal to 4 pi r squared. When r is equal to 5 centimeters, it is decreased by 2%. Decreased by 2%. Find the approximate percentage decrease in the surface area. Okay. before we talk about percentage decrease, we must first of all find the decrease. Then we can now calculate the percentage decrease in reference to the original value. Now, our solution, we have A is equal to 4 pi r squared. Our dA all over d r will be equal to 8 pi and r. And of course, if we evaluate this at r equal to 5, the original value, we now have this to be equal to 8 pi times 5. And that will give us 4 pi square units as area. Now that we have gotten the value of dA over dr, to find the approximate decrease, we say let the approximate decrease be delta A, and this is approximately equal to the dA all over dr, and then multiply by the decrease, and the decrease here is in terms of delta R. We have already gotten our dA over dr. Where is our delta R? Our delta R is said to be 2% of R. So dr is equal to 2% of 5, and that will be equal to 10 all over 100, and that is equal to 1 over 10. So our delta A, the increase or decrease, will now be approximately equal to your 40 pi times your 1 over 10, and that will give you 4 pi. Good. Now that we have gotten the decrease, we are now going to calculate the decrease percent or the percentage decrease. So we do that by carrying out the following operations. Now, our approximate percentage decrease to be equal to your delta A all over the original area, and then multiply this by 100 over 1 in percentage. Now, your A was equal to 4 pi r squared. 4 pi r squared. Now at r equal to 5, your A becomes 4 pi times 5 squared, and that will be 25 times 4, 100 pi. Therefore, the percentage decrease is your delta A, which is 4 pi all over 4 pi all over A, and your A now is 100 pi. Multiply this by 100 over 1%. Pi will cancel, 100 will cancel, and you are left with 4%. So this is equivalent to your approximate percentage decrease. Now let us look at comparing rates of change. Given the equation y equal to f of s, the rate of change of y with respect to another variable t, which is now defined as dy over dt, this means the rate of change of y with respect to t, and the rate of change of s with respect to t, ds over dt, are connected by the equation dy over dt. This means the rate of y with respect to t is equal to dy over ds times ds all over dt. So take note, the rate of change of y with respect to t is equal to the rate of change of y with respect to s times the rate of change of s with respect to t. This is the equation connecting these relationships. Let's take an example on comparing the rates of change. The radius r of a circle is 3 centimeters at a certain instant, and it is increasing at the rate of 0.5 centimeters per second. At what rate will the area A be increasing at that instant? Okay, we have here our solution. Our interest is to look for at what rate will the area be increasing. That is, we are talking about dA all over dt, and this will be equal to our dA all over dr times dr all over dt. Continuing, we have here now that our A, as far as this question is concerned, we're talking about the radius arrow of a circle. So the area of a circle is pi arrow squared, and so we can have our dA over dr here, and that is equal to 2 pi and then r. Then of course we will evaluate this at r equal to 3, so we have 2 pi times 3, and that will give us 6 pi. Now that we have gotten that, our dr over dt is given to us as 0.5 centimeters per second. Therefore, our dA over dt, the rate of change of the area with respect to the time, will be equal to 6 pi and then times 0.5. And when you multiply this, you have 3 pi as the rate of change. And this one is in centimeters square per second.